So welcome everyone to DevDays and welcome to your data in FHIR, how to create a scalable solution. My name is Olthuijsen and virtually with me is Knaap. Christian works for Fireli. He has been working in IT for the past 20 years as a developer, analyst, architect. He's currently the lead developer of the FHIR server. And if you want to reach him outside of the scope of DevDays, you can do that either by email or you can find him on Zulip. This is me, Frank Olthuijsen. I also work at Fireli. I have been working as a software developer and or product owner for the past 20 plus years. I'm currently the product owner of the FHIR server and FHIR mapper. You can also reach me by email or on Zulip. As I mentioned, we both work for Fireli. Today's talk will revolve mostly around FHIR and the FHIR mapper, but we also have other very interesting products like Simplifier.net, Forge, and the Fireli.net SDK. So if you have time, please pay us a visit online at FHIR.ly. And as a little bit of a heads up, FHIR, our FHIR server, probably known to a number of you, will be in the very near future renamed to the Fireli server. So that's a little bit of a DevDays only heads up. Our target audience for today will have a high-level talk. I'll start briefly with setting the context from a functional perspective, high level, and then Christian will create a high-level overview of the technical infrastructure side. So we're targeting architects, we're targeting integrators, and of course we're also targeting developers, but there will be no code involved in this talk. The agenda. So before we go into the how, we begin with the why. Why is there a need for scalability? And I'll demonstrate that with a use case. Then Christian will take over and show you what architectural options and considerations there are and relate them back to the use case. And lastly, we'll try to answer any questions there might be. Now, what is the question? The question is how to create a scalable solution. So in this talk, we're not focusing on greenfield FHIR implementations, but on scenarios in which there's already a significant amount of non-FHIR data. This is a scenario we encounter often with our customers. Now, this data needs to be mostly partially exposed as FHIR, and that can be for multiple reasons, of which we'll name a few. In the beginning, it might be mostly reading the data, but eventually writing will also become necessary. So the overall need for exchanging FHIR data will grow over time as the requirements in the organization grow, but also because the more FHIR data you have, the more external systems want to use it. So in this talk, we'll try to give you some ideas on how to design your infrastructure so it can grow when demand increases. Now, there are, of course, two sides to data, and in this case, FHIR data. It's providing the data and it's reading the data. And here you see a few possible triggers for providing existing data as FHIR. So it can be that the government imposes certain regulations like we see with the ONC and CMS. Maybe you want to allow people to use your data in a personal health environment. Or it could be that there's a requirement from quality registries to provide your data for further analysis. Then we have accepting FHIR data. And here are a few examples of that. So the CMS example is that payers are required to exchange patient data when a member moves to a different health plan. App developers who want to allow their users to not only see their health information, but also add information to it. And from a health information exchange perspective, for example, the general practitioners, they don't even only want to read their patient data, but they also want to add to it, of course. So let's look at an example. On the left, you see a hospital with a number of source systems. So we have a picture archiving system, we have a laboratory information management system, and EHR. And all the information from the source systems is flowing into the CDR, the clinical data repository. Now, at this point in time, all this data is non-FHIR data. On the right, outside of the scope of the hospital, we see an app, which could be, for example, the personal health environment app. We see the general practitioner, and we see a quality registry. Now let's take a closer look at the quality registry. So what a quality registry does is it collects information on the outcome of treatments, and then they use that information to assess which factors lead to the best results. And based on that, they offer suggestions for improvement. Now, a patient comes into the hospital, a diagnosis is set, treatment is applied, and eventually the patient is released. And during this process, information is read from and written to the EHR, and that information eventually ends up in the CDR. Now, let's say that there is a quality registry interested in information on a specific treatment. That information needs to be extracted from the CDR and provided to the quality registry in a format that it understands. And there are some potential issues with this process. So it could be, for example, that not all the required information is registered during the diagnose, treatment, and release process. The CDR information needs to be converted to the format specified by the quality registry, and the mapping needs to be maintained. So if something changes on either the CDR side or the quality registry side, the mapping needs to be updated. Validation is only done at the side of the quality registry, and if it fails, then the provided data needs to be corrected. Usually that means gathering manually the information, correcting the information, and correcting the information is mostly done on the set of data that's being exported and not in the source system. Now, since there are multiple quality registries with each their own data format, the potential problems can increase rapidly. In the Netherlands alone, there are 133 quality registries. So even if all the mapping of data to and from the quality registries goes well, it's still a cumbersome process since each of these quality registries has its own data format. Now, it won't come as a surprise that FHIR can help a lot. So let's assume that the hospital can provide the data in FHIR and that the quality registry can read it. The quality registry can create a profile that the hospital can easily use. Since profiles are very well documented, it's much easier for the hospital to create a mapping. Furthermore, we can validate the data based on the profile before sending it over. And last but not least, the mappings can be reused, for example, by creating a superset of the data for all the quality registries and then filter on it per quality registry. And this already makes your solution a lot more scalable. Now, the whole purpose of a quality registry, as I mentioned, is to come up with suggestions on how to improve treatments. This information can be fed back to the hospital and used for clinical decision support. That way we can increase the likelihood of all the required data being entered during the diagnose, treatment, and release process. So we've now seen one scenario in which we provide FHIR data back to an external system. That system enriches the information and provides it back to us. We've also seen that the demand for providing data can increase greatly over time. Just keep in mind these 133 different quality registries. So we can assume that something similar applies to the other use cases as well. In this case being the app and the general practitioner, but of course there are many, many more use cases. So if you look at the use case that we just briefly discussed and the requirements coming there out of, then we need to be able to handle the growth of data within a use case. We need to handle an increase in the number of use cases. And apart from just getting the data from A to B, we also need to transform the data, we need to validate the data, and we need to filter the data. So with these requirements in mind, I'd like to hand over the presentation to Christian, who will show you a number of ways on how to design your infrastructure to handle these requirements best.
Thank you, Frank.
I have stopped sharing.
Yep, and I will start sharing mine. There you go. So, welcome. And to set the scene on what we're trying to solve here, Frank did the use cases, and I will try to set a slightly more architectural scene where many organizations, as already depicted, already aggregate their data in a CDR or some other form of gathered data. There's often also a HL7 version 2 message exchange system within the hospital. And for many source systems, that is the only information exchange mechanism there is. It's the only way to get some data out of it or into it. Lastly, there are often CDA documents available. That is common in the US situation, a little less so in the European situation. And maybe one of the participants can enlighten me on the Asian situation on this. But these CDAs may have duplicate info because they are document oriented. So the same information about, let's say, a patient may be repeated over and over again in the different documents. Now, we will focus on the first bullet in the diagrams first and add the other two later on. So what does that look like in a diagram? Simply this. We have a gap. We have the source system, a CDR, and then an external system that wants to receive that data in FHIR. You see different kinds of arrows in the diagrams all over. The actual arrows depict the flow of data, and there are two icons. Let's say whether the data is pushed, like here from the source systems into the CDR, or whether it's being pulled out of it, like the external system is doing through the FHIR RESTful interface. I quickly name the FHIR RESTful interface. There is a separate session fully devoted to that tomorrow by Abel Enthoven. So the first solution that comes to mind for many people and is to have a facade. A facade as in a slim component in front of your existing data that just translates the data on the fly. That translation, however, has to go two ways, because if you support the FHIR RESTful interface, you will need to support search, or at least read, which you could see as a search on IDs. So this search must be translated into SQL or some other language that is understood by your CDR. And then when the CDR returns its data, you have to map that data back into to the FHIR resources that are being expected by the external system. So it's a two-way translation. Now, to make this a little more easy, we offer the FHIR facade that takes away as much work of this as possible. Of course, there are other solutions as well. The other architectural pattern is to not have this facade as a front to your CDR, but have a separate FHIR server out of the box with its own database with FHIR resources. Now, from the CDR, you need to capture all the data changes and publish them to the FHIR server. Somewhere in between, you will still have to do that data transform, because in the CDR, there are probably tables, and in the FHIR server, there have to be resources. So you still have to do that transform. Your organization is the one that knows what that CDR looks like and how the data is formatted within it. So you should be the one to transform it to FHIR resources. It can be done more easily, for instance, with the FHIR.NET SDK, which offers you programmatic support. And there are libraries as well for many other programming languages. So now we add some more sources, and it becomes more difficult. So we have an external system that provides us with CDA documents. We have a V2 broker that provides us with V2 messages. And they all need to go to that FHIR server to be published to the external systems that want to use that FHIR data. And in between, what is happening there? We call that the FHIR flow. A bit likewise to on the left, where you have ETL, probably fairly well known, extraction, transformation, and loading, well known in the business intelligence world. We need something similar here, but then for FHIR data. What could that look like? This is an image of how that could look. On the left, we still have the sources, the CDR, CDA documents, version 2 messages. And we provide connectors for all of them, a kind of a sink where this data can go. That sink will then generate messages. So it will separate out the data, it will generate a message that can then be distributed in the FHIR flow. Different messages may need different handling. The trick of the FHIR flow is that these are reusable components organized in separate flows per type of message. For instance, you see 3 of the mapping blocks here. That's usually the first thing you'll want to do. Map the source data into FHIR resources. The sooner you do that, the easier it is to have other components work only on FHIR data and make them more reusable. An example in this image is the validation, maybe the filtering. Validation is very well defined for FHIR resources and can be described by FHIR profiles. It can then be automatically evaluated on FHIR resources. So that's very useful to have. Consulting a master patient index to see which patient this data is actually about could also be easier if you're only talking about FHIR patient resources instead of patient information in all kinds of formats. So based on the type of message, a route is being chosen through this FHIR flow, and in the end, it could be sent to the FHIR server for storage. Or you could do something else with it, of course. Now, it gets a little more complicated if we also want to write data in FHIR. So the app or the other system generates data in FHIR resource format, and we want to add that back to our systems. Usually that's not enough. These apps or external systems always want to read existing data as well. So we need both. And here's how we can do that. First, if we have chosen the facade, it's here in front of the CDR, and then the external system wants to write back. Now, more often than not, the system feeding the FHIR facade, right here, the CDR, is not actually fit for writing data back into it. The CDR is meant for feeding data in bulk or batches from the source systems through the ETL layer, and that makes it fairly unfit for transactional updates coming from the FHIR facade. It could lead to performance problems on the transactional side because of locking on the batch side, etc. Table structure may be a misfit. So you have trouble with that push of data from the FHIR facade to the CDR. Therefore, we do not recommend that approach. The solution would be to split it up. So the app can read from the FHIR facade as all the external systems can. But if it generates data, it gets a FHIR server at its disposal to send this data to store it, and eventually read its own data back as well if it needs to. So it's always real time on its own data. But then from that FHIR server, you could initiate a second FHIR flow to get the data integrated into your source systems or into the CDR. In this picture, you see depicted the FHIR flow from the FHIR server back into the CDR. So that would involve a mapping back to the tabular format expected by the CDR. You could also imagine having a FHIR flow transforming this to a HL7v2 message, feeding it back into the EHR. So you can still reuse the same components in a FHIR flow. Let's say you chose the other solution, a FHIR server having FHIR flows feeding the data into it. Now the external system could read and write to the same FHIR server, or still to two different FHIR servers, depending on the load on the primary FHIR server. From here, you can still start a flow back into what here is depicted into the version 2 broker. Obviously, for the quality registry case, that Frank explained, it would be very interesting to consult this data directly from a CDS hooks application. CDS hooks, where CDS stands for Clinical Decision Support, is a standard that is related to FHIR, and it allows you to put a hook into your EHR, which can then pop up where needed and get more data from a FHIR server to help the doctor make the right decisions on the right stage of treatment. So there you can use the FHIR data directly, either coming from the external system or collected from the source systems. This might sound all a bit theoretical, and it's all PowerPoint boxes. So we decided to translate this into an actual cloud environment, in this case, the Amazon Web Services cloud environment. Of course, a similar solution exists for Azure and for Google Cloud. So what would it look like then? We still have the three sources on the left to feed all that data into your system. And they all get their own endpoints. So for the CDR, we create an API gateway that will then provide an HTTP endpoint to send, for example, CSV files. After that, there is a Lambda function separating the data out, putting it into an S3 bucket for storage, and sending out a message depicted here with the two curly braces, and putting that message on the simple queuing service for further handling. If we have a V2 message system, we create an MLP endpoint, which is the protocol spoken by HL7 V2. There's another Lambda function. A Lambda function, by the way, in AWS is a serverless function. So it's a fairly lightweight piece of code that can be instantiated real-time on the fly, and the cloud environment can instantiate as many of them as needed in a particular time. So in this case, there one is instantiated for data coming in at the MLP endpoint, and it will separate the message out to the S3 bucket and send the message on the queue with the metadata about it. And lastly, maybe the CDA system can put the CDAs directly in the bucket, where the Amazon S3 system will generate an event captured by a Lambda, which will then transform that into an event to be put on the queue. So all these three Lambdas generate similar messages with having data about where did the message come from, what is the media type of it, so what format does it have, where is the data stored, so that will be a link to the S3 bucket, who sent it, so what is the security information connected to it, and what other steps have already been applied to it. On the upper left, you also see the identity and action management for managing our resources in the cloud, and Cognito for recognizing users utilizing our resources. Cognito is an extensible system where you could also add custom functions, for instance, to provide scopes that are required by Smart on FHIR. At this point in the FHIR flow, we have everything in the queue in the middle. From here, we can start workflows based on the type of the message. One is actually depicted on the upper right. It's called a step function in AWS. And in that step function, you orchestrate Lambda functions. And each of these Lambda functions relates to the components that we described earlier in the presentation. So there is the FHIR mapper as an implementation of a mapping function. And in this case, we have a flow where first the mapping takes place, and then afterwards we have to translate some terminology. And And then lastly, there's a Lambda that can translate that into a FHIR REST call to the actual FHIR server to have it indexed and stored durably. And from there, the external system could just use the RESTful API, the FHIR RESTful API to the FHIR server to access that data. From the step functions and all the individual lambdas and all the other components in the system, they can log information to Amazon CloudWatch, which is used to monitor the performance of all these components. Then from the SQS, there is another arrow going to Amazon Kinesis. Kinesis is a streaming system, much like Kafka, for those who know that. And you could also put the raw messages into there before they are mapped to FHIR. And sometimes that is desirable because you want to capture the original meaning of the message for some reason. One reason might be, for example, that version 2 messages are meant to convey an event happening in the hospital, whereas FHIR resources are meant to capture the current state of data. And there is kind of a mismatch between that. So you can still map the data involved, but if you need that meaning as well, you might want to have a direct link. On the other hand, once the data gets to the FHIR server, it too can emit messages, and it could send them right into the same Kinesis system for handling it, for downstream processes, as we call it. Whereas the upstream is everything getting into the FHIR server, and downstream is everything after that. Of course, for durable storage, we need a database, and here we depicted the Amazon document DB. Depending on the FHIR server you choose, that may be an option. In our case, Vonk will support both SQL Server and MongoDB. This is how the whole flow looks. Well, what does that mean for scalability? Because that was the original question. We provide two ways of scalability here. The first one is functional, and that was already kind of touched upon by the example of the registries by Frank. If you have to serve like 50 different registries, you want to reuse mappings, reuse these blocks. So in these FHIR flows, you can reuse the different blocks. And within those blocks, you can also reuse logic used by them, like actual mapping files, FHIR profiles, and they could even be provided by other partners. On the technical side, we can benefit from the cloud environment. This will be less likely achievable on your on-premise solutions. This was clearly made for the cloud, whereas all these lambdas functions and the step functions are serverless, and they can be automatically scaled by the cloud environment without too much interference and management by you. Storage provided in the cloud is usually elastic in nature, so it can grow along with your demands. You can run FHIR servers, at least the Vonk one, in Kubernetes, or even within a Lambda, whereas Kubernetes allows for its own scalability, and the Lambda scalability would be provided by the cloud environment itself. So the whole thing about this is you get to start small with a single external system, with a single source system, with a single flow, a small instance of a FHIR server, and you get to grow along the way with your needs, reusing what you already built. In the cloud image, I also mentioned the downstream processes. Now you have all this data in FHIR, and it can generate messages out of it. You can also do something with that. So you can use those queue messages or stream notifications to pick them up and do something useful further down your system. You could create another FHIR flow to go from FHIR to other formats. We've seen that previously in a slide, to either go to a V2 message stream or to a tabular format that can be read back into the CDR, etc. You could do that to support a publish-subscribe mechanism. And we've even seen a customer implementing the FHIR subscription specification with Lambda functions in a step function. So that was very interesting to see, and it's very, very scalable, of course, so to thousands of subscriptions. You could also do real-time analytics, whereas this streaming mechanism of Kinesis or other streaming mechanism can feed data into the real-time analytics where the figures move as kind of a window in time. Many of the cloud providers offer AI solutions, and this is a good way to tap into it or actually provide it with the data from FHIR. And I know that at least both Microsoft and Google are heavily investing in AI with FHIR. And there is also a talk by Lee Serpent from IBM on using AI in their environment. So you can benefit from everything these cloud providers already have in terms of functionality and building blocks once you have this data in a central place and messages about them. To summarize the solutions we discussed, first is a out-of-the-box FHIR server where you feed data into. Second is the FHIR Facade that you give a two-way translation, so it queries the source systems directly and translates the data back out. To actually feed a FHIR server, we invented the FHIR Flow, and it consists of components like a mapper for mapping data structures, a validator for making sure your FHIR data is valid according to profiles from others or yourself, and terminology to make mappings from, let's say, something expressed in SNOMED that you actually need to be expressed in LOINC, etc., etc. And in this FHIR flow, you can mix and match these components to get the output that you want. Then, often we get the question, do we need the facade solution or the server solution? So I created this table with a comparison for you to check it out. And I will go through the several items. First thing is that in a facade, you need to map the data to FHIR. And in the case of Vonk, it needs to be done in C#. On the server side, you still need to map data to FHIR, but now you can do this in a FHIR flow within any tech stack you like. Secondly, on the facade, you also have to map the search from FHIR into SQL or whatever API is available to call your source system. Again, if you choose to use Vonk, you do this in C#. If you use the server, then the search is fully built in. You don't need to do anything about it, including includes, excludes, whatever, chaining, all the advanced search features that are in the FHIR RESTful API. The facade can be real-time. That said, it can be as real-time as the source system. So if the facade is on the CDR, you still have the delay that the CDR introduces. If you have it on, for example, your EHR directly, it is actually real-time. On the server, you need to track the changes and propagate them to the server, so there will be a certain delay. The facade will put pressure on your source system. All these searches will translate into live queries on your source database, which is also used by the initial system running on it. If that is your EHR, so your users might be affected. If it's the CDR, other consumers of it might be affected. On the server, of course, you need an extra server and database to host all this data, but then the load is off your source system. And you can steer it much more because you push it from the source system, and you can do that in a window where the source system is not too busy doing other things. The facade reuses the source data and the server duplicates the data. That might be a problem or not. The facade works best with a single source. That makes it manageable to implement. It's a bit harder if you want to do multiple sources. For a server, multiple sources are no problem. You just make sure you have multiple of these FHIR flows to get that data in. Data must be authorized in a facade. You can't just query everything from the outside. And so if you get a RESTful call, you have to translate that authorization into the query into your source system. So to make sure no data comes out that shouldn't be coming out. On the server side, you could move that filtering and authorization at least partly into the transformation in the FHIR flows, where you say, I just filter out whatever is not meant for publication and anyway on the FHIR side. As for the Func server, it supports plugins for a lot of functionality. For Facade, you have most of them available for the server. All of them will work. The most notable plugins that are hard to get to work in the Facade, or not at all, is the subscriptions plugin and the history plugin, because that means that your source system must support all historic resources as well. And the bulk data export plugin, because that is highly optimized for the way the server stores its data itself. Lastly, deployment options do not really differ between the Facade and the server. You could use everything from a Docker container or that contained in Kubernetes or binary executables, etc. Now, when you need to make this decision, it's useful to have an example at hand. Let's say you want to support the resources defined by US Core, or not actually defined, but filtered because they're already defined in the FHIR spec, of course. This US Core is the basis for the ONC and CMS rules. So it is very likely you will need to support them, at least if you're in the US realm. It supports read-only access. So that would say you could probably easily use a Facade, but it also already includes 18 different resource types, and on them 76 different search parameters. So if you want to support all of them, that will be some implementation at least. But if you support only 5, 7 resources because you don't have any more data in your sources, then the Facade might still be a viable option. So it might depend on how many of these you provide, how comfortable you are in programming in the technology stack that your Facade server provides. So as always, we started with the question, how do we get a scalable solution? And the answer is, it depends. But I hope we have given you some ideas to think about how you could achieve this.
We have some interesting questions, Christian. We have a few minutes left. Can I read them for you?
Sure.
So this is a question from Stephen Musoke. He says, is there any simpler version of the setup for a regular service, especially in government-driven investments where AWS or Azure are not options and fewer moving parts are necessary? That's quite a long question, but
yes, it's quite. It looks like the question needs to be, are actually 2 questions. Is that true?
Yes, I think the primary focus is it should not be in the cloud. And if there is a simpler setup for this to achieve scalability, that's how I read it. And Stephen, if I'm phrasing it wrong, please unmute and correct me.
Yeah.
Yes, but that is correct. This is Stephen. That is correct. Essentially, I've seen about 6 or 7 components, but many times we need about 2 or 3 because really the resources are in a government data center. You can only get very few servers and things like that. That's why I used government also, because we're not allowed to put, especially in African countries like where I live and come from, we're not allowed to put anything in the cloud. It has to be local. So that's an additional constraint because it's highly regulated.
Yes.
Okay, thank you. Christian?
I can answer this best from the perspective from the FHIR server, because that's the one we know best, of course. And in that case, you could move much of this functionality into plugins in the server, and much of it is actually already provided. Like a mapping functionality can be run within FHIR already. It could pick up, it could map V2 messages, and it could map CDA message documents. So that would make it, that would let you concentrate all the functionality within that single FHIR server. And that is very well doable, but you cannot scale out individual components based on their needs. So if suddenly an enormous stream of V2 messages need to be processed, then the whole FHIR server needs to scale up for that. Whereas otherwise, in the cloud environment, you might be able to only scale up the flow that handles that. So that would be the difference. But at least with the FHIR solution, it would be certainly be possible to have this in a more in a setup with less components and less servers. Does that answer your question?
I guess so, and otherwise
Yes,
let's take it offline. Okay,
Yes,
thank you, Stephen.
Yep.
We have 2 minutes, so I think we can squeeze in one more. It's again a double question, but I'll stick to the first part. Which step in this architecture do you find is normally the bottleneck in terms of processing? And that's a question asked by Miles Bell.
Yeah. It depends. Actually, what we find that the processing ultimately could be limited by the database of the FHIR server, because the other ones can be more easily scaled. But eventually, there is one pipeline from the FHIR server to the database, and if that is a problem that you need to even separate out the different functions of the FHIR server itself, like indexing the data and storing the data. That we find is usually the bottleneck, especially in relational databases.
Okay, we've ran out of time, but I do believe there is some time between this session and the next. Maybe we can stay online for a moment longer if anyone has any questions which were not asked online in the session Q&A. Then feel free to unmute and ask them now, and otherwise just drop them in the chat and we'll answer them later.
Yeah. And if no one unmutes, we can still do a couple of questions from the Q&A, of course.
Okay, so Miles Bell says, thank you. So that question is answered. There was one question about CDS hook. Is that some sort of event subscription to the server? Asked by Dimitar Alexov.
No, it is not. A CDS hook actually listens to the EHR. So it is being triggered by the user interface of this EHR. And when it is triggered by the EHR, it gets some context from the EHR, like the patient it is that is in context, or the encounter that is in context. But it's often not enough, and it also gets it also has a reference to a FHIR server to get more data that it needs to be able to help the user at that specific point in the UI. I haven't checked the schedule, but it's not unlikely there will be a session on CDS hooks specifically as well.
Okay, I'm just reading the next question here. There's a question about costs, but I guess that's very specific for the cloud environment used and all sorts of other variables. So let's get back to that one offline. So what if the bottleneck is at the FHIR server? The rest of the pipelines all seem scalable via AWS infrastructure. How will FHIR inserts handle scalability? Well, I think that very much relates to the question you just answered.
Yes, then it will become, it's also possible to separate out these different functions of the FHIR server, like indexing the data and storing it. That will then be at the cost of eventual consistency, by the way.
Okay, then we have another one from Ravati Srinath. When we talk about data aggregation and multiple data sources, data duplication when storing in a FHIR server is a common problem. So for example, patient information coming from EMR and patient summary CDA. And then the question is, at what stage should, I guess, be decided what information to use? So would that be at the merging or at the transformation, or what would be the best point?
Yes, of course, it depends on your organization, but in general, it would be good to know which source system is the truth about, or the master about specific types of resources. And if you know that, you can use the FHIR flows to filter out the data that is maybe included in a V2 message or a CDA document, but of which that source is not the actual primary source. So you just flow through the things that are new from that source and you ignore the rest.
Okay. Then we have another interesting one from Pradeep Bangalore. For use of the data in analytics, etc., we might need patient consent. Is it preferable to have the consent also stored in the FHIR server, or is it good to get this from the source, like CDR?
If you run a facade, it's best you can keep it in the CDR and consult it as needed there as part of your query to get the data out. So if there is no consent, you can't get that data out. And probably you are then also already familiar with the way you stored it in there. You can also store consent in the FHIR server. There's a consent resource even, but there is still some discussion in the FHIR security work group on how to process that and what it actually means and what does it look like. It's not normative yet. So this is not finalized yet in the FHIR world. If you can go with the current consent resources and that would make you feel comfortable, it is possible. But in this case, I think it's easier to keep it in the format where you already have it.
Okay, thank you. So I'm going through the other questions, and I think the only question that remains is the one I just mentioned. The question was, what sort of costs are we looking at in a cloud environment for large-scale environments with many messages per hour? But I'm quite sure that both you and me can't answer that question.
No, I'm afraid not. I think cost management in any cloud is something you only know afterwards. At least that's our experience with the Azure cloud. So I think you need to do that for your specific situation to guess what types of messages and how many you will have and how many processing power you will need for it. The whole idea of this architecture is to start small. Often you can even start in a free tier in the cloud and then see how far that gets you and then make a much more well-educated guess on how much it costs when you scale up.
Okay, excellent. It looks like we have gone through all the questions. So if anyone has a question, then speak up now.
We probably also need to give the participants time to get to the lounge or get some other social activities.
Yes, good point. So let's leave it at that. Thank you, Christian.
Well, thank you very much, all the participants. I see some familiar names and many, many new. So thanks for listening and enjoy the rest of the conference.
Yes, have a good DevDays. Hope to see you all in one of the breakout sessions, meetings, social events, etc.